Welcome all to my lesson on the fundamentals of OOP, or Object-Oriented Programming. This is meant to be an overview for all, a refresher for the beginner computer scientist as well as the pro, a little rusty on some of their definitions. It's important to go back and make sure that all definitions are consistent so that communication from one to the other, pro, rookie, or whatever, stays smooth and consistent. You don't want to have a misconstrued definition slowing you down when you could just be moving forward on the more difficult task of actually making the system you are tasked with. So we start with the humble OOP. Now, I'd be a liar if I didn't start this out by saying I find acronyms to be very spooky. They are obscuring the real definition of things so that you can have a cute name, and people tend to throw them around really easily. So to me, the first place to start when trying to define something is the definition. Object-oriented programming is a programming paradigm based on the concept of objects, who would have thought, which contain data in the form of fields and code in the form of procedures, or we'll refer to them more as methods. Okay, we have that definition, but why is it important? Well, there are going to be some key terms I'm going to say a lot, like all the time. And that's because with that type of redundancy, we will learn them more easily and effortlessly and learn how to use them in a conversation. So those terms will be objects, fields, and methods, which will be covered later on in the course. Let's work through this table. I want to break down what OOP really is. So we start with object, the first O. An object refers to a particular instance of a class, where an object can be a combination of variables, functions, and data structures. Okay, what does that mean? An object is kind of like a container of different bits of data, and it will use it in a certain way. But we'll go into that more later. Oriented, the second O, just means focus or based on. And then programming, coding or design. So we sum that all together, and we get a way of thinking, or coding, focused on how objects interact with one another, and how the developer wishes said objects are implemented and used. It's very important to understand that the key thing here is objects. I hope I delivered that clearly enough. To say, the objects will hold our information and it will pass it on and allow for others to manipulate and move it as it sees fit. And using that, we will actually be able to create an environment of objects that will encapsulate what we are trying to do. So a quick overview of all the things I want to cover in this lesson. The first thing being an object's anatomy. It's important to understand the different pieces inside of the object, as were described on the previous slide, to understand why we use them later on. And this will be when we really crack down on definitions and terminology, so that there is no confusion in later lessons. We also will deal with interactions between objects. So objects in an environment, how they interact with one another and manipulate each other. So the key word here will be access modifiers. We'll talk about how that data gets obscured and controlled and kept consistent so that we can have a proper answer come out from all of it. And the last topic I want to cover in this whole lesson will be kind of summarizing why even use an OOP. And it's the sweet pillars of OOP. I say sweet because we have another acronym here, API. And though I am sick of acronyms, this one is actually quite useful. The pillars are the fundamentals, the whole name of the course, of what you gain from using an OOP. And they mainly work on maintaining consistency and reducing redundancy in code. And we'll see how that works when we get to the end of this lesson.